Factoring by completing the square. What's unique about completing the square method is it's the only factoring method where you don't want your expression equal to 0. It's set up where it's equal to 0 right now, x squared plus 6x minus 7 equals 0, but we actually want to change it where it's equal to the constant. And the constant in this case is -7. It's called a constant because there's no variable attached to it. So we'll add 7 to both sides, and it becomes x squared plus 6x equals 7. Then what we do is we actually add something to both sides. And what we add to both sides is a number that we get from b divided by 2 squared. And remember, b is from the 1, 2, 3 of the trinomial. It's a, b, c. So our b term is 6. So we're looking at 6 divided by 2 squared. 6 divided by 2 is 3. Squared is 9. So we add 9 to both sides. And that's one of the keys to this problem, is remembering that you have to do b divided by 2 squared and add that to both sides. And so on the left we have a trinomial, x squared plus 6x plus 9 equal to 16. And we factor the trinomial on the left, and it should factor to the same binomial twice, x plus 3, x plus 3. And so we write it, instead of as a binomial twice, as a binomial squared. And that's why it's called completing the square. Now x plus 3 squared equals 16, and to solve for x, to get rid of that squared, we do square root of both sides, and the square root of x plus 3 squared is x plus 3, and the square root of 16, we do square root of a number, you get two answers, one positive, one negative, so plus or minus the square root of 16 is 4. And then lastly, we need x alone, so we have to subtract 3 on both sides, but remember we have plus or minus 4, so -3 plus 4 is 1, and -3 minus 4 is -7, so we get two answers. Now what's different about our second example? Well, there are going to be a couple of differences we're going to see, but the first thing is that there's a number in front of x squared. For completing the square, a must equal 1, meaning there cannot be a number in front of x squared like 2. So we want to get rid of that. We're going to divide everything by 2, so then we don't have a number in front of x squared. So x squared minus 8x plus 11 equals 0. So now it's like our first example. We need to set it equal to the constant, so subtract 11 on both sides. B in this case is now 8. So b divided by 2 squared would be 8 divided by 2 squared. 8 divided by 2 is 4. Squared is 16. So we add 16 to both sides. On the left, we're going to get a factors to x minus 4, but I write it as x minus 4 squared. On the right, -11 plus 16 is 5. And then square root of both sides. We get x minus 4. When you square root of x minus 4 squared, it's just x minus 4. And the square root of 5 is plus or minus the square root of 5. See, in our last example, over here, when we did square root of the number on the right, we did square root of 16, but 16 was a square number, so it just became plus or minus 4. 5 is not a square number, and so it's just plus or minus 5. If it were something like 20, we could reduce it, but still we're going to have a radical in our answer. And adding 4, we can't add 4 and a radical, so we have to write our answer as 4 plus or minus rad 5.